Hello everyone, in this section we will mainly discuss the key frames of WLAN. Firstly, there are three main types of key frames in WLAN. The first type of frame is the management frame. The second type of frame is the control frame. The third type of frame is the data frame. Three different types of frames. Management frames are mainly used to supervise and check the joining or leaving of terminals from the wireless network. That is the purpose of management frames. They handle matters related to connections, such as negotiating network access or checking the range of the wireless signal, etc. All these tasks related to connectivity are performed by management frames. What do control frames do? During data transmission, for example, the previously mentioned RTS, request to send, CTS, clear to send, etc., are used to control the transmission and forwarding of related data frames. That's the purpose and function of control frames. Data frames are simple. They are used for data transmission. These are the three major frame types in the 802.11 protocol. What specific frames are there? Understanding these frames will be useful when troubleshooting later, so we must pay attention. First is the beacon frame. What is a beacon frame? It is used to announce the presence of a network, and the AP sends this beacon frame periodically. The range of the beacon frame is the range of the SSID that can be reached by the beacon frame emitted by the AP. So, it is important to understand the function of the beacon frame. The second is the probe request frame. Probe request, our terminal, also known as STA station, uses the probe request frame to scan for various SSIDs around, to see the different 802.11 networks available, such as employee and Huawei guest. When scanning, we can see which of these two networks, such as employee and Huawei guest, we can connect to. The third is the probe response frame. If a STA scans and finds a network and wants to join, it will send a request, and the AP will respond with a response to answer. After sending the last beacon frame, the AP must respond to the received request frame. After responding, it starts sending beacon frames again. The remaining frames are quite common, namely the authentication and deauthentication frames, as well as the association and disassociation frames. These are some of the contents of the management frames. After discussing management frames, we move on to control frames. Control frames are quite familiar to everyone. RTS is request to send, CTS is clear to send, and ACK is an acknowledgement. The AP must send an ACK to confirm after successfully receiving data. This is how it works. The last one is the PS poll, the power save poll frame. This is used in power save mode. In power save mode, the AP will cache the frames that need to be sent to the terminal, and then it sets a flag in the beacon frames sent to the terminal. When the terminal wakes up from power save mode, it checks the status in the beacon frames. If the status is set to 1, it will request the AP to resend the cached messages that were stored earlier. These are then retransmitted to the terminal. This is the PS poll mode. These are what we refer to as control frames. Finally, there are the data frames. Data frames don't have any special types, just simple data frames. These are the key frames of WLAN. These frames are used to carry the entire wireless network. We'll continue with the third part, about STA going online. This part discusses how the STA goes online to the AP. What is the process like? Let's take a look. First, we see that the terminal's access process uses entirely management frames. Whether it's beacon frames, probe requests, or authentication requests, all are management frames. Only after the terminal goes online and starts sending data do we use control frames. It's important for everyone to understand this. Then let's look at the terminal's access process, which is divided into 3 stages. The first stage is the scanning stage, periodically scanning for available wireless networks nearby. This is why having Wi-Fi on drains battery. As long as Wi-Fi is on, even if you're not connected, it continues to scan for networks available nearby. The second is the authentication stage, which is when accessing the WLAN network. undergoing identity verification, and performing link authentication. The third stage is the association stage. After completing link authentication, the STA initiates negotiation for link services. This is an overview of how terminals interact with the AP. Now let's look at the details. The first stage, scanning. Scanning is divided into two modes. The first is active scanning, which involves periodically searching for nearby wireless networks to gather information about nearby wireless networks. One way of active scanning involves carrying an SSID with a specified ID. For example, carrying the Huawei label indicates that the terminal wants to establish a connection with the Huawei SSID, signifying an intent to connect. Only then will it carry your SSID. The second is active scanning, with an empty SSID, for instance. The terminal sends a probe request, but this probe request contains an empty message. The SSID is null. SSID null is essentially a query mode, asking the AP to inform if there are available wireless services in the area. This method aims to acquire available wireless services. To see which networks are accessible, it is crucial to understand the difference between carrying an SSID and not carrying one. With active, there is also passive. In passive scanning, the AP sends a beacon frame to the terminal, and the terminal is compelled to accept the information from the AP. After receiving information from the AP, one knows there's no need to send probe requests, thus conserving resources. This is the purpose of the AP sending beacon frames. The AP sends beacon frames at a cycle of 100 TUs, where 1 TU equals 1024 microseconds. This unit is particularly small, hence the frequency of sending is quite frequent. This is the passive scanning method. Passive scanning has a characteristic: it only listens to beacon frames, does not send probe requests, so it might take a bit longer to get the AP list. Unlike active scanning, which is faster, it takes a few more seconds. This is a feature of passive scanning. After completing the scanning, link authentication begins. There are two types of link authentication. One is open authentication. The other is shared key authentication. Open authentication means you can go online without authentication. The second is shared key authentication. Initiating shared key authentication means the AP sets a password and I, the terminal, set a password. If the passwords match, there's no problem. The terminal sends an authentication request to the AP. Then the AP generates a challenge, which contains a phrase of a specific message. The STA then uses my original password, for instance, brings its own password, combine it with the challenge message to generate an encrypted challenge, which is the encrypted challenge sent to the AP. After the AP receives the encrypted message, it decrypts the message using a preset key, then compares the decrypted challenge phrase with the one previously sent to the STA. If they match, authentication is successful. Otherwise, the authentication fails. This is how link authentication works. The third step is association. After completing link authentication, the association request is initiated. Firstly, the STA sends an association request to the AP. This request includes various parameters of the STA and various parameters chosen according to the service configuration, including supported rates, supported channels, and capabilities such as QoS. After receiving the association request frame, the AP encapsulates it using CAPWAP and reports it to the AC. After the AC receives the association request, it determines whether user access authentication is needed and responds with an association response. Finally, after the AP receives the association response, it encapsulates it using CAPWAP and sends it to the STA. This is the process of association. After completing these three steps, the terminal can go online normally. In this part, we have introduced some key WLAN frames and the process of STA going online. In the next lesson, we will introduce the principles of roaming and several roaming modes. Thank you, everyone. See you in the next class.